In this video, we'll introduce the Keychain solution template for secure data transfer. This template allows you to build applications for secure transfer of data, including messaging, documents, photos, and all other types of data. In this particular video example, we show this template being used for secure messaging between multiple parties. Keychain Core is a software framework that implements off-chain data security and application-level consensus based on-chain self-sovereign identity. Our partners integrate Keychain Core into their applications and systems to manage identity and security in a zero-trust way on a wide range of devices. Developers can interact with Keychain Core in three ways: the native SDK, a command line interface, or hosted web API. This gives developers flexibility on how to integrate Keychain Core into their systems natively. Using Keychain Core is very easy. This solution template is comprised of three steps: persona creation, pairing, and secure data transfer. In persona creation, you create a digital identity that is stored on a blockchain. By pairing your devices, that digital identity is exchanged with another person. And after devices are paired, secure data transfer can then take place with any data on any device. Any data includes messages, photos, documents, data files, contracts, etc. And by any device, Keychain works on tablets, PC laptops, Androids, iPhones, smartwatches, and IoT devices. We'll start this demo with two devices, John's device on the left and Sally's device on the right, both Android phones. First, you will set up a persona name on each device. Starting with John's device, you will add a persona name of family. So here we show video of two devices running the Keychain solution template for secure data transfer. Once downloaded and installed, you will select Create New to create the personas, and then type a persona name of family for this example, and then type in the name John. Now let's add a persona name to Sally's phone on the right. Again, you will select Create New. You'll enter a persona name of family. Then you'll enter a name of Sally, and then hit Create. Now, you're going to add a second persona on John's phone, and you will see the benefit of this later in the video. So select Create New again on John's phone, and make an additional persona, and we'll name that persona Medical. And we will type in John again. When you select Create, you will see 5 automatic steps that will be displayed and executed: created, funding, broadcasted, confirming, and then confirmed. You will see this in the video demonstration, but it has been sped up to make the video shorter. The steps of initially creating a persona can take 5 to 10 minutes, as the process is creating and confirming digital identities on the blockchain. Next, you're going to pair devices. So for this example, John wants to pair with Sally, both under the personas of family. You will display the QR codes and scan one phone QR code to another. Here you see John's phone scanning Sally's QR code. When you pair these two devices, you are sharing the digital identities of these devices between the two. You'll see the contacts have been added under the personas. Since John shared a persona of family with Sally, Sally's contact shows up in John's list of contacts. And conversely, John's contact is visible under Sally's persona of family. Now, secure messaging between these two devices can be conducted. In the video demo, you will see a set of message exchanges between John and Sally. As mentioned earlier, this particular video shows chat, but this solution template can be modified and adjusted for documents, contracts, photos, and all other types of data. So here in the video demo, you'll see messaging back and forth between John and Sally. This communication is secure and end-to-end encrypted. And here you see Sally sending a message back to John. And then you'll see one more set of communication between these two. On this particular demo, you see John sending a message to Sally, asking Sally if she's talked to Mom lately, and then Sally replying. Now, this is a good time to introduce a third device for this video to demonstrate secure data transfer between multiple devices. Let's add a third device on the far right called Mom's device. Mom has already created a persona on her phone, a digital identity that can be shared with the others. We will display the QR code on Mom's device, and both John and Sally compare with Mom. You simply start by having John scan Mom's QR code, and then you will see Mom's contact show up under John's family persona that he shared with Mom. Next, you will scan Mom's QR code with Sally's phone, and now all three devices have shared their digital identities with each other. Now you can have secure chat between Mom and her son John. You will first switch back to the person's name on each phone. Again, this is a template, it's not a fully functioning messaging application. So you would build out features that match your company's needs. After selecting contacts, you can then perform secure end-to-end encrypted messaging between John and Mom under the family persona. On the video demo, you see John sending secure messages to Mom, and then Mom sending secure messages back to John. This is secure because these devices recognize the digital identity when they were paired earlier. Next, you will do the same thing with Mom and Sally. Select Mom on the contact screen of Sally's phone, and then you type a message from Sally's phone to Mom's phone and vice versa. You can do some additional messaging back and forth as seen in this demo. And for one more example, you can perform a group chat between all three. To do this, select the contact list icon on the bottom of the screen and then select all. And then you can perform secure chat between all of the devices at one time. This can be done because all devices have shared their digital identities with each other, and secure transfer can be executed between all three. This could be used, for example, a family chat like you see here in this demonstration, or in different business scenarios of a corporation where there are many different scenarios of sharing secure data between individuals or an entire group that can be applied. So here you see John sending a message and everyone else in the group receives it. No one outside of this persona group can receive this message or decrypt it. So now you have seen an example of secure data transfer in a group scenario. Next, we're going to show you the use of the second persona that we added to John's phone in the beginning. Having multiple personas gives you the ability to compartmentalize and separate sections of your social life and activities. Each persona has a different public key and private key, therefore a different digital identity. Now, in the beginning, you added a second persona on John's device and named it Medical. You could use that second persona to pair with his doctor, for example. Now, you can introduce another device, an iPhone, for this part of the demonstration. Let's call it Dr. Giggles' device. Dr. Giggles has already created a persona for his patients, and he decided to name it Healthcare. You can name personas whatever you like. What matters is that you are able to create multiple personas and keep different parts of your social graph separated. For this example, John has one persona for family and an additional persona for medical-related secure transfer of messages and other data. So you could share the medical persona QR with Dr. Giggles. After pairing, you see that Dr. Giggles shows up under John's contact under his medical persona, and that John shows up on Dr. Giggles' device under his healthcare persona, which he uses for patients. You can also edit the name. So in this case, Dr. Giggles would want to change John to his entire name and other patient contact description. So in this example, John Levy, first and last name. Persona names can be different on each user's phone for identity. Now that you have updated John's name in the doctor's phone, you can send secure messages between John and his doctor. The second persona that John created has a completely different digital identity than his family persona. Therefore, separating these two different sectors of his social and data interactions. Here we see secure messaging between John, his doctor, and John. And John replying back to his doctor. Now you have seen a demonstration of the Keychain solution template for secure data transfer using messaging in this scenario. You saw the three basic steps in using Keychain. 1. Creating a persona, a digital identity on the blockchain. 2. Pairing, where you shared that digital identity with another person. And 3. The secure transfer of data between devices based on their digital identities. You saw a demonstration of secure data transfer between 2 devices, 3 devices, and then all 3 of those devices in a group scenario. You also saw secure data transfer with an additional persona and the benefits of having multiple personas to separate different sectors of your activity. The Keychain solution template for secure data transfer can be applied to many scenarios across enterprises. From secure data transfer between internal company business units, or compartmentalized and separate identity and secure transfer of data across enterprises.